Hello everyone, welcome back to my YouTube channel. I'm posting this video after a long time. I've been quite busy and I'll try to keep up with making more videos, informative videos about Gaussian and GaussView and some other useful software in computational chemistry. So today's video is about drawing electrostatic potential maps and getting information out of them, and looking at the molecule, its maximum and minimum potential areas, like where the charges are either maximum or they are either minimum. So I'll walk you through it one by one. So first of all, I have an optimized molecule here, and I also have its fcheck file. If you have run the calculation on Windows, you're good with the checkpoint file, but because this calculation was done on Linux, so I have formatted its checkpoint file to use on Windows. So if I drag and drop this fcheck file onto the Gauss view, I can see the molecule. This is a CH3I. And to get its molecular electrostatic potential map, we'll come to Results, Surface or Contours, and then in Cube Actions, I'll do a new cube. And here I'll select Total Density and check the full density matrix. In newer version of GaussView, you can also increase number of processes to make things quick. And if I click OK, it will calculate the cube. And here is the total density cube calculated. So now I will plot the density using the surface actions, and I'll do new mapped surface. And if I do it number of processes 4, click OK. So here we go. We have the density plotted, a mapped surface plotted on it, but as you can see that you can only see the green color. So I'm not sure why GaussView doesn't make a good guess at giving the values in an appropriate range so that you can see the electron rich and electron poor areas. So you have to play a little bit with the scale yourself. So because it's a neutral molecule, I'll go from maybe -1 to +1. Nope, didn't work. So I'll reduce this one to 0.5 and this one to -0.5. Nope. So let's do it 0 and this one 0.01. Yep, we got it. So you have to play a little bit with the scale to have a look where is your appropriate scale that gives you what is exactly happening in this molecule. So basically you can see that this CH3 is attached with an iodide. So the density of iodide is shared between the iodine and this carbon atom, and which in turn makes some density, puts some less electron density on the other side of iodide, which is this area. And as you can see that this area is showing a bit partial positive, and then that is in the middle. You can see the green color which is around, and then of course all the other electron density is on the iodine here. And here the hydrogens are very much having their electrons with them because of this Ci bond in this molecule. So now you can also see these things. If you have the fcheck file, you can open it in multi-WFN. Let's do it. So I have MultiWFN 3.8, and if I open this fcheck file, so I'll just drag and drop it here, and then I press enter. It gives me various options, so you can do a lot of different analysis with MultiWFN. We'll talk about them at a later time, but at this time we are only interested in the analysis of molecular surface. You can see this number 12. So I'll write 12 and press enter. Now I am in the menu of quantitative molecular surface analysis, and if I want to do the analysis, I'll press 0. Otherwise you can select different settings like electron density, which is 0.001 at the moment. You can change it, you can do all the different settings, but I'll just go with 0 and start the analysis. So now it has done the analysis. Now you can view the molecular structure, surface minima and maxima by again putting 0. So if I press 0 and enter, this window opens up. So now you can see there is a little drawback that you cannot really click and drag and rotate the molecule, but you can do it with these buttons up, down, left, right. Okay, so I'll just turn off the axis to make it a bit clear, and now we have these blue dots, which are the minimum positions you can see from here, and red dots, which are the maximum positions. So the maximum positions are where the potential is maximum, in more partial positive, and the blue dots represent the more electron rich areas actually. And if you click on these maximum labels, you can see the labels. I'll just remove the position so you can see 1, 3, 4, this is 2 and 5. So now if you look at their value, so this is 1 in front of this hydrogen, and if you look back here on this window, you can see that the value of this potential is 19.77 kilocalories per mole. So that is the value of the surface potential here, and which is a Vs max value, and you also have its coordinates. So if you want to plot it with a different program, you can do it. You can save these coordinates by the option export surface Extrema as surface analysis.txt in the current folder, and then similarly you can have a look at the minima, which are the electron rich areas, so which will be shown with a negative sign, and that's how you can view a molecule's surface extrema, which also tells you the values of sigma holes. So if you have learned about the concept of sigma holes in the halogens, you can check it online and see what a sigma hole is. So it is right in front of the iodide, which is this number 4. So you can get the sigma hole value as well from here. And the surface extrema, which is the maximum one, is right here, number 5, and you can see a star with it that represents the maximum value. So that's how you can analyze the electrostatic potential maps, and also the areas which are electron rich and electron poor. So this way you can also know that the bonding behavior of this this molecule in the reactions. So if you're doing the reaction mechanisms and such things, you can have a look at the surface extrema electrostatic potential maps, and you can have an idea of the molecule, how it should behave in different environments, if it comes across a nucleophile, if it comes across an electrophile, and yeah, in these kind of situations. So I believe that's enough for this video, and I'll try to make some more videos about multi-WFN and getting different properties from multi-WFN using an fcheck or a wave function file. And thank you very much for watching. If you have any questions, you can post in the comments, and I'm also trying to make a website which link will be given in the description, and you will also be able to contact me through there. Thank you very much. Bye bye.